Welcome everyone. Today I'll walk you through liquid penetrant examination or PT, one of the most powerful NDT methods used in industrial inspection. Principles, applications, and inspection guidelines based on API 577 and ASME Section 5. We'll cover how it works, where and when it's applied, and the rules that guide its use. Please be informed, this summary is intended to simplify the content based on the presenter's interpretation. What is liquid penetrant examination or PT, liquid penetrant testing or LPT, also called dye penetrant inspection or DPI, or penetrant testing or PT is a common, low-cost, non-destructive method for finding surface-breaking flaws like cracks and pores in non-porous materials such as metals, glass, and some plastics. The process involves applying a colored or fluorescent liquid penetrant, removing excess from the surface, and then applying a developer which draws the penetrant from any flaws, making them visible. Liquid penetrant examination or PT general overview. PT, or liquid penetrant testing, detects surface-breaking flaws in both ferrous and non-ferrous metals, commonly used on stainless steel, where magnetic particle testing isn't suitable. Liquid penetrant testing or PT can be applied to weld joint surfaces, intermediate weld passes, and final welds. Penetrant materials must be low in contaminants, such as chlorine, sulfur, to avoid damaging the metal. Standard liquid penetrant testing or PT systems work up to 125 degrees Fahrenheit or 52 degrees Celsius. High-temp systems are available for hotter surfaces. Penetrant techniques. There are two main techniques. Number one is color contrast, red dye on white background. And number two is fluorescent penetrant, visible under UV light, used in dark rooms for fine cracks. There are three types of penetrant systems: solvent removable, water washable, and post-emulsifiable. Before use the penetrant techniques, ensure compatibility with the metal and weld type. ASME Section 5, Article 6. Given recommended requirements, must follow a written procedure including, choose the type of penetrant. Solvent removable, water washable, or post-emulsifiable, cleaning and drying steps. The surface of the part to be tested is cleaned to remove dirt, grease, and other contaminants that could interfere with the test. Penetrant dwell time. The penetrant is allowed to dwell on the surface for a specified time to give it a chance to enter any small surface openings through capillary action. Developer application and interpretation time. A developer, often a fine white powder or liquid, is applied to the surface. The developer acts as a blotter, drawing the penetrant out of the surface flaws. Evaluation based on code standards with minimum lighting, visible or UV. The part is inspected under appropriate lighting conditions, where the penetrant drawn out by the developer creates a visible indication of the flaw against the contrasting background. Post-cleaning. After inspection, the part is cleaned again. Process of liquid penetrant examination or PT or dye penetrant inspection or DPI. Process step number 1 is, principle, uses capillary action, low surface tension liquid enters surface cracks. Process step number 2 is, application, penetrant is applied by dipping, spraying, or brushing. Process step number 3 is, penetration time, allow time for the liquid to seep into flaws. Process step number 4 is, excess removal, wipe off extra penetrant from the surface. Process step number 5 is, developer, apply developer to pull penetrant out of flaws, making them visible. Process step number 6 is, inspection, check under UV light for fluorescent dye, or white light for visible dye. Sample of acceptance criteria. When indication type is linear, ASME Section 8 and ISO 23277 Level 2. Given this linear indication, a rejection if greater than 1.5 mm. When indication type is rounded, ASME Section 8 and ISO 23277 Level 2. Given this rounded indication, an acceptance if less than or equal to 3 mm. When indication type is cluster, ASME Section 8 and ISO 23277 Level 2. Given this cluster of indication, a rejection if spacing less than 3 mm. When indication type is crack and lack of fusion, ASME Section 8 and ISO 23277 Level 2. Given both crack and lack of fusion, a completely rejected. Thank you.